All right, so this section is 1.6a. We're going to start solving other kinds of polynomial equations. Right, so we've done quadratics so far. Right, so we're just going to continue solving equations. So these are polynomials, so with higher exponents. Right, it's going to be pretty much the same thing that we've been doing, right, factoring mostly. All right, so I'll show you some examples. So to solve polynomials, again, most can be factored. Typically, we always start by factoring out a GCF. This third bullet where it says if the variable of the first term is the square of the middle term. All right, that's not going to make sense to you guys yet, so we'll do that when we get there. Right, but there's a special way to solve those kinds of equations, and you're going to see, I think number 6 is a question like that. But for these first two, we're just going to factor as normal. All right, so looking at number 1, right, it says 3x to the 4th equals 48x squared. All right, so in the last section, before we factored, we wanted the entire equation set equal to what? To 0, right? So let's do that first. Let's subtract 48x squared from both sides, and we should get 3x to the 4th minus 48x squared equals 0. All right, now that we did this, we can factor by taking out a what? Okay, a 3x squared, right? We can take out a 3x squared, and we're left with what on the inside?
X squared minus
16, right? Good. X squared minus 16 equals 0. Now you can keep factoring, right? I'll do that. I'll show you the other way. Right, but we can keep factoring. How is x squared minus 16 going to factor?
square rooted.
Okay, so it's a difference of squares, right? So we get 3x squared on the outside, and then we get x plus 4 times x minus 4 equals 0. Now that it's fully factored, right, just like in the last section, we want to set each factor equal to 0. All right, we set each factor equal to 0, so we get 3x squared equals 0, x plus 4 equals 0, and x minus 4 equals 0. All right, have a good one. And solving this first one, we can divide both sides by 3. Right, I'll write it up here. We should get x squared equals 0 divided by 3 is just 0. All right, and then to get rid of that square, we want to square root both sides. All right, so we should get x equals, anytime we square root, we want to have a plus or minus, right? But plus or minus 0 doesn't exist, right? There's no positive or negative value. It's both 0. So you can just write x equals 0 and you get an answer. Right, notice though that 0 is an answer, but we had to square root to get that. Right, so we get 2 answers here and they're both 0. Right, and you don't have to write this down, but this, we call this a multiplicity. Hold on, let me write this down. Multiplicity of 2, right? So if it shows up twice, again, you don't have to write that down because it's not useful to you guys yet, right? But that just means we get an answer twice, right? So we get x equals 0 twice. All right, so those are 2 of our answers, and then our other 2 answers. All right, here we just want to subtract 4 from both sides. All right, I'm running out of room, but we get x equals negative 4. And then here we can add 4 on both sides, and we get x equals positive 4. All right, so x equals 4, negative 4, and 0. Right, now just like our section with quadratics, notice that the highest exponent here is a 4. Right, that's going to give you some clue as to how many solutions you should get. Right, I know I circled only 3, but again, we count x equals 0 twice. So we should get 4 solutions here if our highest degree is 4. You also could have, if maybe you didn't think to factor the difference of squares, from this step, you could have just set each factor equal to 0. Right, so you could have done 3x squared equals 0. and x squared minus 16 equals 0. Right, and then you get the same x equals 0 here, but here you would just add 16 on both sides, and then you get x squared equals 16. Right, just don't forget your plus or minus after you take the square root. All right, so plus or minus 4. Still get the same answers. Right, because you guys know how to solve quadratics now, you can do that, right? That's fine. Okay, I'll leave this up, but I'll start the second one. Right, second one, same thing. It's already set equal to 0, so the first thing we want to do is what?
Factor.
Okay, let's factor. How are we going to factor this one? Okay, you can take out a GCF of 3x squared.
No,
Oh, you're going to, okay. Okay, so let's take out 3x squared. Whoa, hang on. All right, when we take out a 3x squared, what are we left with on the inside? All right, good. We get 3x squared minus 4. All right, and then from here, we can just set each factor equal to 0. Right, we don't factor 3x squared minus 4. It doesn't factor nicely, so we just set them both equal to 0. So we get 3x squared equals 0. 3x squared minus 4 equals 0. All right, and now here we divide both sides by 3. It looks like we get the exact same answer as the last one. For one of our solutions, x squared equals 0. Square root both sides, x equals 0. Right, so to get this 0, we had to square root. So this accounts for 2 of our answers. And then to solve the other one, right, we just want to get the x squared by itself, so we want to add 4 on both sides. We get 3x squared equals 4. And now you can divide 3 on both sides. And we get x squared equals 4/3. And now we square root both sides. All right, so we get x equals what? What would our final answer be? All right, square root. All right, well, first we need a plus or minus. Right, and then how can we simplify this radical? Okay, yeah, so you can square root the top and square root the bottom, right? If you have two things under a radical that are being divided, you can square root both of them, right, separately. And then square root of 4 gets you 2. And then square root of 3 you can't simplify, right? Now are we done? All right, why not? You have a radical in the denominator. Very good, right? So we want to rationalize that. So let's multiply the top and the bottom by square root of 3. So you get x equals plus or minus 2 square root of 3 over 3. Right, so that accounts for 2 of your answers, right, the plus or minus. And then x equals 0 showed up twice. That accounts for your other 2 answers. Remember, the highest exponent gives you a clue as to how many answers you should get.
The highest exponent?
Mm-hmm. Highest exponent. So here the highest exponent over the variable is a 4.
4. So we have 4 answers.
You should expect to see 4 answers, but again, 0 we got from square rooting. So 0 shows up twice.
Oh.
Right, and then plus or minus 2 square root of 3 is your 2 answers. All right, are we okay with that one? Okay, so let's look at the next one. All right, this one we have 4 terms here. We have an x cubed minus 3x squared plus 3x minus 9. How did we factor 4 terms?
We split them into 2 terms.
Okay, good. We want to factor it by grouping, right? Group the first 2 and group the second 2. Right? Anytime you see 4 terms, you can factor it by grouping, right? And then GCF of the first group is going to be what? We can take out an x squared. Nice. And then you're left with x minus 3. All right? And then GCF of the second group, you can take out a 3. And then you're also left with x minus 3 equals 0. All right, and now x squared plus 3 become their own group. Right, and since x minus 3 matches, that also becomes its own group. All right, now that we factored it, we can set each factor equal to 0. So we get x squared plus 3 equals 0. And we get x minus 3 equals 0. Right, one of our answers is going to be 3, right? We can add 3 on both sides. And we get x equals 3, right? One of our answers. What's our other answer going to be? Square root of 3, that's it? All right, so we want to subtract 3, right, on both sides. Okay, so you get x squared equals plus or minus square root of negative 3. How else can we write that? Bless you. Awesome, good, yes. Anytime you see a negative under the radical, take out a what? I, right? Oh, I didn't even square root that, right? Sorry. So you should get x equals plus or minus I square root of 3, right? That's going to become a common occurrence, right? So we're done with no solution. Anytime you see a negative under the radical, you need to take out an I. All right, questions on that one? All right, I'll leave this on the screen, but you guys try number 4. Okay, so let's give this one a try. So good, looks like some of us got it. We want to group, right? Anytime you see 4 terms, you want to factor it by grouping. Right, so group the first 2 and group the second 2. The GCF of the first 2 should be an x squared. And on the inside, we should be left with an x minus 5. All right, GCF of the second pair should be a negative 2, and we pull out a negative 2 so that the insides can match, right? And then we get an x minus 5, all right, equals 0. All right, and then x squared and minus 2 are the GCFs. We can pull that out. And then bring x minus 5 in its own group, equals 0. All right, now that we factored it, we can set each factor equal to 0. So x minus 5 equals 0, and x squared minus 2 equals 0. And now to get one of your answers, you just want to add 5 on both sides. And you get x equals 5. And one of your other answers, you can add 2 on both sides, and we get x squared equals 2. All right, and to get your answers here, you want to square root both sides. You should get x equals plus or minus the square root of 2. Yeah, so that was a good point, right? So your highest exponent here is 3. So you should expect 3 answers, right? X equals 5 is one of them. And 2 of your answers came from this plus or minus, right? One is positive square root of 2, and the other one's negative square root of 2. Okay, let's keep going. Let's try this page now. All right, something like number 5. It's already set equal to 0. You want to find a what here? You want to take out a what?
GCF.
Okay, you want to take out a GCF. What would your GCF here be? 3x, right? Good. Let's take out a 3x. All right, take out a 3x, and what are you left with on the inside? Okay. Good, we get 2x squared. Good, minus 9x. And then minus 18. Right, we take out the 3x. And now we want to see if we can factor the inside. So let's see if we can factor 2x squared minus 9x minus 18. All right, so I'll make that x. All right, let me do it in black. All right, so when the first term is not 1, we want to multiply 2 times negative 18. Should get us negative 36. And we want to see what multiplies to negative 36 and adds to negative 9. Can we think of two numbers? All right, negative 12. Positive 3. All right, what do we do with these two numbers now? What do we do with our negative 12 and 3? All right, since our first term is not 1, we split up our middle term. So we get 2x squared minus 12x plus 3x minus 18. All right, and then don't forget about that 3x in front. Equals 0. And now we want to group. All right, so let's group the first two, group the second two. GCF of our first group, we can take out a 2x. And you're left with an x minus 6. GCF of our second group, we're going to take out a 3. And we're left with an x minus 6. All right, equals 0. And then again, don't forget about that 3x out front. All right, so all of this is times 3x. And now on the inside, we can do 2x plus 3. All right, and the insides of that match is going to be an x plus 6 or x minus 6. And then again, we have a 3x out front. And now from here, you just need to set each factor equal to 0 and solve, right? I'll do that off to the side. All right, 3x equals 0. You just have to divide by 3. And you get x equals 0. Right, we can do 2x plus 3 equals 0. You just want to subtract 3 on both sides. And then divide by 2. We should get x equals negative 3 halves. All right, and then x minus 6 equals 0. We should get x equals 6. All right, so we should get 3 answers here. All right, so let's try number 6 now. All right, number 6 looks a little different. Is there any GCF that we can take out? All right, there's no GCF. Doesn't look like we can group or do anything like that. All right, so we can't use our normal methods here, at least not the way it's written, right? But we can make it look like something that we know how to solve, right? I call these quadratic-like polynomials. Right, I call them quadratic-like polynomials. Why? Because they're polynomials that are like a quadratic, right? It's what it sounds like. You can solve them, right? Meaning you can solve them the same way that you would a quadratic equation, right? But we're not going to have just an x squared and an x, right? We're going to have higher exponents here. What you should notice about these, right, and this is going to work for any case like this, is that your middle exponent is going to be half of your biggest one. If it's half of your biggest one, you can rewrite it to fit more like a quadratic. So we can say x squared, right? You guys agree that's the same thing as x to the fourth? Right, power to a power, you multiply the powers. So this is the same as x squared minus 3x squared, right? Nothing else changes. Plus 2 equals 0. right? Some of you might be able to see it right away, what we can do, right? But I'm going to write it out this time. All right, and now that it's set up like a quadratic, we can factor it the same way. Right, we have something squared, that same term, and a constant. Right, so we're just going to look what multiplies to 2 and adds to -3. Right, is going to be -1 and -2. Right, but we're not just going to have an x here. Right, because our middle term was an x squared, we're going to make this an x squared minus 1 and an x squared minus 2. And you can verify that this is correct just by foiling it out. If you foil it and you want to check, it's going to be the same thing as this up here. All right, and that's always how it's going to work out. So again, you can factor it the same way you would a quadratic because it is like a quadratic. Right, but again, instead of an x, you're going to have an x squared. All right, is that okay with everyone? All right, we're going to do some more examples like it. So, And now that it's factored, you can set each factor equal to 0. Right, so x squared minus 1 equals 0. And x squared minus 2 equals 0. And then we just get our x squareds by itself. Right, so we can add 1 on both sides. We get x squared equals 1. Square root both sides, we should get x equals plus or minus 1. All right, same thing for the other one. We want to add 2 on both sides. We should get x squared equals 2. And then square root both sides, we should get x equals plus or minus the square root of 2. All right, and we get 4 answers here, right? Plus or minus 1, plus or minus square root of 2. Again, your highest exponent should give you a clue as to how many answers you should get. All right, let's try the same thing with the next one. All right, can we do this one the exact same way that we did the last one? All right, what do we think? All right, if we want to solve it like the last one, how would we do that? Okay. Okay, good start. So we can do an x squared, right? So you're going to factor it, right? It's what multiplies to 12 and adds to -7, but we don't have an x squared and an x, right? We have an x to the 4th and an x squared. Again, it's always going to be the case if your middle exponent is half of your biggest exponent, you can factor it like a quadratic. It's going to work exactly the same way. Just instead of x, you're going to have an x squared. So we're going to have x squared minus 4, right? What multiplies to 12 and adds to -7 should be -4 and -3. So x squared minus 4, and we get x squared minus 3 equals 0. All right, that okay? You guys agree? And now we set each factor equal to 0. X squared minus 4 equals 0. X squared minus 3 equals 0. And then we just add 4 on both sides to solve this one. We get x squared equals 4. And then square root both sides, we get x equals plus or minus 2. All right, and for our other one, we want to add 3 on both sides. So we get x squared equals 3. And then we want to square root both sides. So we get x equals plus minus square root of 3. All right, so again, 4 answers here. All right, so this one, again, we can solve it the same way. We just want to factor. This time there's something in front of our x to the 4th. Right, so we want to find what multiplies to 9 times 4. Right, so 36 and adds to -37. Right, should get you -36 and -1. right? And then you can split up the middle term. So we get 9x to the fourth minus 36x squared minus x squared plus 4 equals 0. Again, solve it the exact same way that you would a quadratic. All right, and now we can group. Take out a GCF. GCF of the first group is going to be a 9x squared. And then you're left with x squared minus 4. GCF of our next group, we can take out a negative 1, right? We want the insides to match, so let's take out a negative 1. All right, and so we get 9x squared minus 1 times x squared minus 4 equals 0. And like I said in the beginning, you could factor all the way, or from here you can set each factor equal to 0. If you want to factor all the way, right, both of these factors are difference of squares. Right, so the first factor, we can separate it into 3x plus 1 and 3x minus 1. And our second set of factors, we can separate into x plus 2 and x minus 2. All right, equals 0. And then just set each factor equal to 0 and solve. Plus 1 equals 0, 3x minus 1 equals 0, x plus 2 equals 0, x minus 2 equals 0. Right, now if you solve all of these out, you should get x equals negative 1/3, x equals positive 1/3, x equals negative 2, and x equals positive 2, right? 4 answers. If you like to see the 4 factors so that you can see your 4 answers, you can do it that way. Or you can do it the same way that you've been doing it before and just set each of these factors equal to 0. All right, so then to solve these, you can add 1 on both sides and you get 9x squared equals 1. Divide by 9 on both sides. And then you get x squared equals 1 over 9. Square root both sides, you should get x equals plus or minus 1/3. Right, same thing as before. Same thing over here, you can add 4 on both sides and then we get x squared equals 4. Square root both sides, you get x equals plus minus 2. Right, so the exact same answers as before. All right, it's a little hard to see, so let me rewrite it. All right. All right, really quick, I'm going to do number 9. Right, it looks a little bit different, but you guys have done something like this before. How do you get rid of that denominator? You're going to multiply everything by x squared. So we should get x squared plus 3x squared over x equals negative 2x squared over x squared, and now things are going to cancel. All right, x squared over x is going to cancel. We get x squared plus 3x equals, and x squared are going to cancel, is going to equal negative 2. Now we can add 2 on both sides. So you get x squared plus 3x plus 2 equals 0. And now you can just factor and solve. Right, this is just going to get you x plus 2 times x plus 1 equals 0. So you should get x equals negative 2 and x equals negative 1. Now, anytime you have a variable in the denominator, you want to check for extraneous solutions. Right, we don't get any here. Right, so you don't have to check here. It's fine.